All right, this is the 8.7 Day 1 video. The objective of this lesson is to multiply numbers in scientific notation. Before we get to that part, we need to go over two things. So the first thing is kind of remembering a skill that we had learned before we were off. And then the second thing is a quick skill that we'll need to use when we're in the middle of some of these problems. So for multiplying exponents, remember when we had something like number 1, 2 to the third times 2 to the second. This meant 2 times 2 times 2, and then we were multiplying by another 2 times 2, which when we look all in a row, that is 2 to the fifth. In number 2, we have 9 to the fourth, so 9 times 9 times 9 times 9, and we're multiplying by 9 to the third, so 9 times 9 times 9. And again, when we see that all in a row, we know that that is 9 to the seventh. Okay, so if you recall, the operation we're doing with our exponents is addition. So in number 1, 3 plus 2 gives us 5. In number 2, 4 plus 3 gives us 7. So we can apply that rule to number 3 and 4. Okay, so in number 3, that base would stay the same, so negative 7 stays negative 7. The exponents would get added, so 3 plus 5 gives us 8. In number 4, that base stays the same, so 5/8 stays 5/8. And then even though our exponent is negative, we can still add it together. So 10 plus negative 2 is positive 8. Okay, so remember when we're multiplying our exponents, or multiplying our powers, the exponents get added. Okay. Now, one quick skill we'll need in some of these problems is to rewrite the following numbers in scientific notation. So as you look at A through F, they all sort of look like scientific notation, but they're breaking the rule that your number has to be between 1 and 10. So for instance, in A, we have that number 73.2. It needs to be 7.32. That number needs to be between 1 and 10. So these are almost sort of in scientific notation, but not all the way. So what we're going to do is we're going to think of this almost as a balancing act. So in A, our decimal needs to be after the 7. So it needs to be 7.32. So when this decimal gets moved, our number just got smaller by a power of 10, which means that our exponent needs to get bigger. Okay, so that balancing act that I had mentioned, when one number gets smaller, the other one's going to get bigger. Okay, so this would be 7.32 times 10 to the third in scientific notation. Okay, let's look at another one. For B, we have 103.4. Well, in scientific notation, we have to have our number, or our decimal, right after the first number. So we would have 1.034. So from 103 to 1.03, our number is getting smaller by 2 spots, which means our exponent needs to get bigger by 2. So this would become a 10. In C, we have 0.004 times 10 to the fifth. To be in scientific notation, this would need to just be a normal 4. So in this case, we would have to move the decimal 3 times to the right. So from 0.004 to regular 4, our number is getting bigger by 3 decimal places. So to balance it out, that exponent needs to get smaller by 3 decimal places. So this would be 4 times 10 to the second. In D, we have 73.2 times 10 to the negative second. For scientific notation, it has to be 7.32. Again, this is making our number smaller to go from 73 to 7. Our number is getting smaller by 1 decimal point. So our exponent needs to get bigger, so we would need to add 1. Negative 2 plus 1 is negative 1. In E, we would need to have our number be 1.034. So this is going to get smaller by 2, which means our exponent needs to get bigger by 2. So this would have to become negative 6, because negative 8 plus 2 is negative 6. And then the last one, again, this needs to be a regular 4, so our number is getting bigger by 3 spots. Since the number is getting bigger, the exponent needs to get smaller by 3 spots, so that would become negative 8. This is kind of a tricky skill. And again, I like to think of it as balancing. So when one thing gets bigger, the exponent gets smaller, or if the number gets smaller, the exponent gets bigger. If you need to rewatch this section, please do so, because I know that this can be a little bit tricky. Okay, so the objective of this lesson is to multiply in scientific notation. So what you're going to be given is two numbers written in scientific notation. So for this one, we have 2 times 10 to the second times 8 times 10 to the negative fifth. Now there's really multiplication between all of these. So we can rearrange this using the commutative property. So we can put the 2 times 8 first, and then our powers of 10 second. Well, we know that 2 times 8 is 16, and then with our powers, we're going to add those exponents. Okay, that was our skill review we did at the beginning. So adding our exponents gives us 10 to the negative third. Okay, now again, this number is not fully in scientific notation because your number has to be between 1 and 10. 16 is not between 1 and 10. So in this case, we would have to use the skill that we talked about above. Our decimal would have to move to the left 1, so our smaller by 1. So our exponent has to get bigger by 1, which gives us a final answer of 1.6 times 10 to the negative second. Okay, let's go over some examples. So in number 1, we're going to take 7.1 times 10 to the 8th and multiply by 3 times 10 to the 8th. Okay, so we're going to multiply our numbers together and then our powers together. So 7.1 times 3 gives us 21.3, and then our exponents would be added. So 10 to the 8th times 10 to the 8th, we add those exponents to get 10 to the 16th. So we would get 21.3 times 10 to the 16th. Now this is not fully in scientific notation because our number needs to be between 1 and 10. So we would need to move our decimal over once. So we would have 2.13. From 21 to 2, our number is getting smaller by 1 spot. So our exponent needs to get bigger by 1 spot, giving us the 17th. In number 2, we're taking 2 times 10 to the negative fifth and multiplying by 6.2 times 10 to the negative third. So again, we're going to multiply our numbers together and then multiply our powers of 10 together. So 6.2 times 2 gives us 12.4. And then our exponents would get added. So negative 5 plus negative 3 is negative 8. Okay, and again, this answer is not fully in scientific notation because your number is not between 1 and 10. So this decimal would need to move over 1 to make it 1.24. From 12 to 1, our number got smaller by 1 spot, so our exponent needs to get bigger by 1 spot. Negative 8 plus 1 is negative 7. So our final answer would be 1.24 times 10 to the negative 7th. Number 3, we have 8.4 times 10 to the 4th times 3.4 times 10 to the 7th. So again, we're going to multiply our numbers together. So we need to take 8.4 times 3.4. Add those together. Okay, and then remember we have two numbers behind our decimal, so our answer would need to have 2 numbers behind the decimal. Okay, so we end up with 28.56 times 10, and then we're going to add our exponents. So 4 plus 7 gives us 10 to the 11th. And again, this answer is not in scientific notation because our decimal is not in the right spot. So we would need this to be 2.856. Okay, this is making our number smaller by 1 spot, so our exponent has to get bigger by 1, giving us 10 to the 12th. All right, and our last one, we have 9 times 10 to the negative 7th times 2.5 times 10 to the 3rd. So again, we're going to multiply our numbers together. So 2.5 times 9. That'll give us 22.5. And then our exponents are going to get added. So negative 7 plus 3 is negative 4. Okay, and then again, this number is not in scientific notation. We need to make it smaller by 1 spot to give us 2.25. Since our number just got smaller, our exponent needs to get bigger. Okay, bigger by 1 would turn into -3. This skill is a little bit trickier than some of the things we had done in the previous lesson. So please, again, if this is confusing, watch the video again. And you can also look at the video examples in the book to help you out as well.